So let's do some problems here. So you give me the surface area of a cube. It's going to be 900 centimeters squared. Determine the side lengths and the volume of this cube, and we want to work out the surface area to volume ratio. Okay, so last part we'll elaborate on more, but the other parts we can do already. So we know that 900 squares has to be split up between 6 surfaces. And each one of those surfaces is exactly the same. So when we divide that 900 by 6, we get one surface is 500 squares. Okay. Well, if I know the surface of the square area, to go from square area to side length, I square root. So I'm getting 12.25 centimeter side length. Okay. So for part A, the side length we get by finding the area of one square and undoing it with a square root. So the side length, S, we'll say is about 12.25. Okay. So we're going to use this side length then to get a cube. We know this is a cube, so side length cubed is the volume of our cube. So I'm just going to cube this value, and I'm going to get 1,837 point something. So I'm just going to round that to 837.1 centimeter cubes. Okay, so there's my volume. Okay, so once I get the side length, I can cube to get volume. The last part is something new. This volume to surface area ratio. Okay, the volume to surface area ratio is just a ratio where we just compare the volume, 1837.1, to the surface area of 900. Okay, so this is centimeters cubed to centimeters squared. And we can leave it like that, but generally with ratios we want to simplify that. So I'm going to simplify that into unit ratio of 2.04. There's 2.04 cubes for every 1 centimeter square of surface area. So for 1 square on the surface, we get this many cubes on the inside. Now, why we want to know this is because it changes depending on the size of the object and also shape. So the two things that change the surface area to volume ratio. The size, so if we have a congruent or a similar shape but different size, the surface area to volume ratio changes. Also the shape of it. Okay, if we flatten something out, the volume is going to be very little compared to the amount of surface that there is. So if we take a look at this surface area to volume ratio of a 1 centimeter cube compared to 5 centimeter cube, well, the surface area on a 1 centimeter cube, well, there's 6 surfaces on a 1 centimeter cube, and each surface is 1 centimeter squared. So this is going to be 6 centimeters squared. And the cube, well, there's only one cube there, so the surface area to volume ratio, this time I'm going to write the surface area to volume, so surface area of 6 centimeters squared. Okay, the other one was the other way around, the volume to surface area, but the surface area to volume here is going to be 6 centimeter squares for every 1 centimeter cube of volume. That's cube. Okay, so for 1 cube, there's 6 centimeters of surface. If I take a 5 centimeter cube, every side is going to be 25 centimeter squares, and there's going to be 6 of them. So I'm going to go 6 times 25 gives me 150 centimeters square of surface area. The volume of a 5 centimeter cube is going to be 5 cubed, or 125 centimeters cubed. And when I work out the ratio, okay, I'm just going to write it out small here, 150, actually I'm going to write it on the bottom underneath. So I'm going to write it out as 150 centimeter squares to 125 centimeter cubes. Okay, now if I want to compare it to the other one, it's easier to do it as a unit rate. So I'm going to do 150 divided by 25. My unit rate is 1.2. So I get 1.2 squares of surface for every 1 cube of volume. So what happens is the same shape, but as I get bigger, I have less surface for each centimeter of volume. Because what ends up happening is, as I make this bigger, there's more cubes that get hidden inside. So imagine a whole bunch of cubes, okay, like those Unifix cubes. Those cubes get hidden, a bunch of cubes get hidden inside and don't have any surface exposed. Here, this cube has all surfaces exposed, so we have a greater surface area to volume ratio. Okay, so in general, okay, so do the ratios stay the same? No. Larger objects have less surface area to volume. We'll say smaller surface area to volume ratio. Okay, so when we change the size, keep the shape the same, but change the size, this will affect the surface area to volume ratio.